Hello, this is Quinn and Greg. Welcome to our next lab. This one is our spring lab where we're trying to figure out what factors can affect the period of a simple harmonic motion of a spring moving up and down. Material-wise for this one, you're going to want 3 identical springs for each group. So whether that's kind of these fancy hook springs that we have here or just simple springs that you can buy at plenty of hardware stores. Also going to want a variety of masses like the pendulum lab, a meter stick, and then something to hold the springs up. You can see that we're using our same pendulum clamps, but honestly anything that you can hook the springs on that's out of the way. Ring stands work well, anything like that will function for the lab. The final thing, of course, you need is a stopwatch to measure the period on there.
So basically the idea is that this is an inquiry lab, so we're really not telling them at all what the procedure is. We're hoping that they will see what they did last time and they knew they had to vary some things to try to figure out which of those affected the period. And in this case, they have a similar system, but with the masses and springs. So the idea would be for them to, for example, they will put a spring there and put a mass on it, and then they should know enough to keep track of the fact that they have this one spring and they have a mass of some known value, and then they want to find the period that the mass spring system has. So what we suggest for them to do is to don't have them pull the spring down because it'll just launch the thing and they might hurt themselves or wreck the spring itself. But if they just lift it up a little bit and drop it, they'll be able to see this oscillation happening and they can do the timing. And the timing would be done in a similar fashion to the way it was for the pendulum, where they would let me just add another spring here to slow it down a little bit so you can kind of see what's happening. If I add another spring, I think you'll be able to see this better. I'll put a little bit more mass on there too. So again, they start, this is the equilibrium position, and then you would have them lift it up to some amount. And by the way, they did change the amplitude last time, so they might think that they would maybe have a small amplitude and then have a bigger amplitude and so on. Those are the kinds of things you're hoping that they're going to do. And when you go to measure the period, again, they would start, say, at the bottom, and then they would count from there, like 0, 1, 2, 3, 4, maybe up to 10, and they can divide to get what the period is. And we're not really telling them what to do. We're hoping that they're going to think of these different things to try. But the things that we're kind of expecting them to do would be, as I mentioned, to change the amplitude itself. And then, of course, they will probably think to change the mass. So they might, instead of 1 mass, put 2 masses or something. And then, repeat the experiment like that. And again, they just lift it up a little bit and let it bob up and down and try that. The one that they tend not to think of is the variation of the way the springs are oriented. As you saw, when I went from 1 spring to 2, it significantly changed the period. If you put a third one on, it will do that again. And we would call these springs would be connected in series, kind of like a circuit. But the other thing that they probably won't think of, that if you wanted to give them a hint, they could also arrange it in parallel, where they would be connected like this. So you could connect 2 springs. I don't want to bend the spring, but you would just connect it. If I take this one off, if you connected them both onto here and then put the mass onto both of the loops, then you get yet a different situation. Maybe you can see if I pull it off to the side. So we would call that to be in parallel, and that's a different way to arrange the springs.
Now, overall, our big suggestion for doing this lab is to try to give the students as little as possible. Because they had such a big help with the last lab being so similar, this is really a great opportunity for them to get used to these inquiry-style labs where you're not helping them every step of the way and they're kind of figuring something out without you really just leaving them high and dry, because they had so much experience last time. So over the years that I've done it, I find they almost immediately jump to the masses first. They're sitting out there. It's pretty self-explanatory. I find that they do amplitude pretty soon. They tend not to call it that. Maybe occasionally they do. Sometimes they call it length or something along those lines. But as long as they get the idea of, hey, I got something to vary, that works well. And I would say a hint that I give for them to start using the other springs is just I point at what they have in front of them and just tell them, hey, use all your materials that you have. And that generally gets one group or so in the lab section to do it. And then once, one starts doing it, the rest start doing it. And they really get, I think, a sense of accomplishment of figuring it out without you necessarily having to tell them. So as little as possible is kind of the goal.
Another thing is that in the lab itself, there's the top, which has very little information. It's just basically telling them to perform the lab. And then we list some challenges, which you can see if you look in the lab booklet. It's important that they don't do the challenges until after they've done the lab itself, because before they've done the lab itself, they really don't know what factors are going to affect anything, so they wouldn't really necessarily know what to do. But the idea is that the first part of the lab should inform their decisions on what they're going to do for the challenges, and then be able to work it out that way.
And really, you can play however you want for once you want out of them for proof of, hey, what factors did, what factors didn't. In the last lab, in the pendulum lab, we had them make graphs. Sometimes my students will naturally jump right into making graphs and do that, but some of them will just present the data and make the argument there that this really didn't change anything, or yes, this had a big effect on there. So they should really be coming up with that conclusion of, does it affect it or doesn't affect it, which, as Greg mentioned, will help a lot with the future challenges.
Okay.
Yeah.
All right.
That's it.
That's it.